Hello and welcome, dear viewer. Today I'm back to Powder again. Today there's no piano because I couldn't be bothered to open up Ableton Live. Anyways, you're not here for the piano playing, you're here for the programming, of course. So let me actually talk about Powder again. It's a programming language that I am creating from scratch, and it's kind of Rust-like, kind of Zig-like. It should have some form of lifetimes, hopefully. I'm just messing around, trying things out, so on, trying to write a compiler in itself, trying to write something that can generate LLVM, and so on. So yeah, on the right side, you can see a Powder file. And if I open up my terminal and wait for Starship to crash again, because I don't know, let's go into Powder Bootstrap. You might be noticing that I have a different font from last time. I'm trying out the official Microsoft code and terminal font, which is called Cascadia, and I'm also trying out the ligature feature in VS Code, so you get these cool programming ligatures for common, like 2-character and 3-character symbols. This is a bit buggy, but yeah, you probably know what I mean. It's a very nice feature that things like JetBrains Mono has had for a long time, and I wanted to try that out, whether I like the font or not, whether I can read it well, because I'm so used to reading source code pro, but yeah, I don't know. Anyways, if we now get back on topic and try running, wait, I probably have that in my history. Here we go. Yep, we can parse this file into an AST. So that's what we did last time. And or even the episode before last time, because last time we just did some refactoring for today's work, which is to support other expressions. So currently we only support a number as an expression and optionally a plus before it. And that's what this, for example, is for x, which has a unary plus and a natural literal. So yeah, it's rather hard actually. Like, expression parsing is one of the hardest things, because you really have to think about operator precedence and which things you want to parse in which order. However, before I start on worrying about that, I think I first want to like sketch out the AST structure here. So yeah, let's go into the expression enum, and maybe let's actually I was thinking about maybe we should change the unary expression to a more generic unary expression and have like another enum in here that specifies which unary expression we have, because there's a couple of unaries. There is the not, there is the plus, there's the minus, and there might even be others that I'm forgetting right now. Oh yeah, there's the reference operator, which is also technically an expression, or yeah, it is an expression. So I think I want to generalize that maybe. So let's actually try doing that first before we do anything else. Unary operation. So we want a unary operator and a box expression, and we have the, up here for example, we use variable kind. So I think we can just have another unary operator, and we need to derive debug for that, and that can have plus, minus, and not and reference and dereference. I think that's enough for now. So also, before I continue on, I read some Zig code the other day and noticed that this for one, this syntax is exactly what we have in Zig, is exactly what Zig has. And on the other hand, if you look at one of the more complex files, I think it's the optional one. Yeah, so what Zig has, I think, is just, yeah, they have const optional equals enum. Like this. And I thought that syntax was silly, but in fact, that's exactly what Zig does. That's kind of funny. So yeah, I'll stick with this syntax, but it's kind of funny that I discarded that or dismissed it, and Zig does the exact thing. So yeah, I don't know. That's kind of funny, I think. Okay, let's continue here. So now we need to do that, and yeah, I think I can just here unary operation with unary operator plus, and we need to probably include that. And yeah, let's test if that still works. Absolutely, it still does. Now we have, yeah, we have unary operation plus. Cool, so we generalized that already. And we'll actually stay here in the parse expression function for today. So I think actually I'm going to commit that before I do anything else. Okay, so what's this? Oh, we need that as well. Cool. Strap. Support and generalize unary expressions. Okay. Fantastic. So now we can sketch out the AST some more. So the expression, of course, let's focus on arithmetic stuff for today, and I think I'll try to just do multiply, divide, and plus, and so on, and see if I even have enough time for anything more today. Okay, so so the crucial part is you need two different. Wait, no, in the AST you don't need two different kinds of expressions. You need to treat them differently in the parser. Okay, so because yeah, depending on how strongly the operator is binding. So yeah, let's just do binary operation with the binary operator. I think I'll actually make this one a internal struct. Operator is a binary operator. Left is, or let's just do left hand side and right hand side. It's a box expression. Right hand side is a box expression. Okay, and then we need the binary operator. Okay, and let's just do plus minus. Yeah, let's actually name them by the mathematical operation. Multiply, divide, and I think that's all we can do today. This complains about not being constructed, but that's okay. Okay, so now we need to think about parse expression, and that's where like operator precedence comes in. So crucially, we want to try and parse the operation with the highest precedence first, and then subsequently try all the others if that one doesn't exist. So I think for now, the operation with the highest precedence is multiply and divide. So basically what we first try to do is we try to parse a left-hand side, parse that operation, parse that operator, and parse the right-hand side. Now I've done this before, but it's hard remembering the details, how you do that exactly. Because, for example, like unary expressions are the least strongly binding, but they still need to be handled pretty strongly in some ways. I can't remember right now. Yeah, maybe let's actually. If we have something like this, we want to parse an expression, then parse an expression, then parse a multiply, and then parse another expression. And if there's no multiply here, we want to parse an expression, then parse an addition or some other operation, and then parse another expression. So basically what we need to do for the expression parsing, yeah, we need to like limit the number of tokens that we want to parse. So I think we need some more features for that. We can't just like do look ahead stuff. We need to like actually like do things like what you do in formal grammar, where you have productions and stuff. Basically, we need to do something similar. Specify, okay, this is one combined production, quote unquote. Yeah, so token stream doesn't support that right now. What token stream supports is look ahead. How do we go about this? Do we just want a struct that supports the supports like limiting the range? Because here we have an owning token stream. Okay, yeah, maybe we want to do that. Well, this is already prime A. What about we refactor token stream to not own its contents at all? What if we just do this? Now in that case, we can't exactly, now the construction doesn't work this way anymore. That's not possible. Yeah, we can't do this. So yeah, because we need to have an index into valid memory. So I guess what we could do is just return like the modified tokens as well as ourselves. So we can just vec of token prime A and return self and get like, still get like a vec of tokens. Expected 1 of 9 possible tokens. Great. Oh, and of course I need to close that. Yeah, so now this doesn't work. Oh fuck, I think we have a self-reference issue now. We can just let's see if it actually occurs, but I think that's not, we can't do this. Let no comment tokens equals tokens blah blah blah. Then we want to return no comment tokens and return wait, why does that? Oh, it works because I'm still okay. So yeah, so let's mute token data, token stream. Oh, and I have to, of course, mute both of those. Stream. Let's hope that we get an error here, or yeah. No comment tokens doesn't live long enough because it's because Rust doesn't understand that we moved the value, because Rust doesn't understand that we're moving this thing out of the function and that we're referencing something else that is moved out with us. So the reference could just be kept alive if the compiler inserted some smart code to basically move the thing out of the function into the like surrounding scope, stack, whatever, and then reference that new thing that just got moved. That's just not something the compiler or the borrow checker can do right now. And this is one of the biggest problems that the like one of the two big problems that the borrow checker has. One is self-referential structs, so anything that references itself or something that contains itself. And there are some unsafe fixes for that. And the other one is you can't return anything with a reference to itself in the in that way, like in the function. If you return two things from the function and one references the other, just doesn't work. Okay, so so there's workarounds for that, and I think the main workaround is that we like have to create this outside the function. Basically, I think we just have to like do some like internal call some internal secondary function, something like helper. So tokens is a vec of token of A, returns a vec of token of A and self. And it will just do this exact thing, but now it's, I think if I just give it a, wait. If I now do this, that should maybe work. Okay, and then new helper. I can't find the function. Oh, I need to. And now I can't do this because it still references something that doesn't live long enough. Let's put that into the borrow checker. I know there's some sort of workaround where you can just borrow something else. Move, because move, and we move it in here. So now we just get another, yeah, it thinks that tokens is dropped while still borrow, but that is not the case, in fact, and just Rust can't figure that out. Now, what if I just pass that in as a reference and just return this? I thought I wouldn't need to do something like this, but today, but I think we're going to get the same problem. And I can just do that. Explicit lifetime required in the type of tokens. Yeah, so we just specify the lifetime here. Borrow that. It still doesn't live long enough. Maybe it requires that it's okay. I can't figure out the workaround right now. So I'm guessing we have to do that externally. Like get another function, like, yeah, maybe let's just extract the, oh, maybe I just need to strip comments from whatever. Let me just put that in to, and we move the vec into here. And we just return another one of those. And then we just now we can't, we need to somehow avoid, I think, no, it's not possible. It's not possible at all. However, we can now just, we have to do that externally. Like I have to go in here. Where's that? I have to go in here and say that tokens is token stream strip comments of tokens, and now we have to basically just do that, and we actually get a get the reference in here. So we don't need the helper. I think that should be fine. Let stripped tokens and take a reference to that, and now that works. Okay. At least partially. I think this will complain. This can be a const function. This can be a const function. And this can be a const function. Interesting. Cool. We just now actually we have a bunch more const functions. That doesn't help us anyway, but I guess it's nice. Let's see if that still runs. It runs perfectly fine, and we still get unary operation. Okay, so I didn't mess up anything. Let's commit that. I think we can just commit the entirety of the of the parser file. Yeah, okay. Bootstrap. Make token stream take a slice, contain a slice. If we want to have sub streams, we need to make token stream non-owning. God, the line limit. I think I complained about that in some other video. That's probably the most terrible part about anything at all. At least about Git. So now we can create a sub expression. Let's implement that. Make substream. We need to click self and the length use size, and we assume that we are like, we don't just assume, we start at we start at the current index. What is it? I mean, I think I don't need that, but I just need the body now. Okay, so we can just self tokens from self.index dot length, and that's just tokens, and that's self.tokens, and the index is 0, of course, and that likes me to have a reference. Now that should be perfectly fine because we're still referencing the same thing. Cool. So do we have that? So we need that here now. So basically what parse expression should take is not the whole token stream, but just the token stream that contains the expression. And of course, that will allow us to like auto detect the limit of the expression beforehand. Now I don't know how complex that is in general. It might be more complex because things like semicolons and commas can also appear inside of an expression. So yeah, I don't know. That could be rather complex. Or maybe we want parse expression to handle that. Maybe I'll just parse it. I'll just like try and find the limits of the expression outside of the expression itself, so that we can make our lives a lot easier. Yeah, okay, so here we have make substream, so we can look at the initializer. We skip the equals, and then we then we actually need to, and now we can like immediately fork. You can just let expression parser equals token iterator dot expression stream, probably better name. make substream, and that's the token iterator dot length minus. Maybe I want a helper for that actually. Let's just have fork substream, which literally just creates a copy that has the same initial state. Wait, I can just implement clone for that. That's kind of dumb. Can I now just copy? Why doesn't that work? Implemented for parse token tree of a. Oh, because I need to have clone. Clone is the explicit duplication. Yeah, I think I can. Yeah, I can just copy that, right? I can just token iterator. Using clone. Oh, I can just dereference it. Woohoo! And now that is just a copy. Yeah, okay. So now we own that thing. Cool. Because of course, like token stream is now just a pointer, a length, and an index. It's just 3 integers basically. Because Rust slices, of course, have a pointer to the start and then a size. Or do they? I don't even know. Wait, yes, they do. Okay, yeah, they do. Well, it wouldn't make sense with like type safety and stuff. So, okay, expression stream. So I've now forked the iterator, and now I can just I can say expression stream dot limit to first token type semicolon. Of course, that's an API I just invented. But what that would do internally is look for the first semicolon, or the first type back here, in that case a semicolon, and then just yeah, like change the length in such a way that that's the exclusively last element. So that element is not even in the thing anymore. So let's limit to first self type, which is the token, say token type. I will just return self, and now we can while not self dot is end and self dot tokens dot, wait, I can do this more easily with tokens that get current index, which starts out at current index starts out at self.index, and self.get current index +1, and that's a non thing. Actually, nice that they have this. They even have a what you call it, ligature for dot equals range syntax in Rust. So that's rather nice. While let okay next token equals Expected enum option found. What does get do? Returns. Oh, I need some here. It's kind of dumb. For programming too much Serenity OS recently, although there is no such thing as programming too much Serenity OS. Next token dot wait no. If I had like the option of like now putting an and back here, which we discussed a couple episodes back, that's not a stable feature yet, then I could just say and next token is not of this type. So now I have to just do if next token dot type equals type, then we break. Oh, we have to index 0 that. And then we can say the current index is the index of the element. So basically we can just self dot tokens equals self dot tokens from 0 to current index. That compiles. Okay, cool. Yeah, I think because it inherits the lifetime and stuff. So now, of course, that needs to be mutable, but that's not a problem. Let's see if that complains. An inclusive range would be more readable. Yes, I actually do agree. The cool thing would be now, just for the Rust language people, if someone is watching, maybe I'll do that myself, I don't know. But for someone from the Rust team to, or like from the Rust language server people to just, they already have these suggestions like Clippy and the Rust compiler already know what your code could be instead. So why don't you just plug that into VS Code's quick fixes and suggest the quick fix so that I save even more typing time? Like, I mean, even Clang D has that nowadays, so yeah. Yeah, and also current index plus equals 1 before we get ourselves into an endless loop. Before I forget that. Yeah, we don't use mix upstream right now. I'll just leave it in. Maybe I'll need it later. Okay, so let's actually debug the expression stream. Yeah, so for example here, help note, consider importing this macro log debug. They could just like put a quick fix in to do that because Rust C has already found the damn thing. But yeah, I'm getting off track. Use log debug. We need to then do that and expression stream. I need to do this. So now this will crash down here, but let's see if for both of them we can get like a correctly limited expression stream, and for that I also need to. I also already have that. Okay, so let's run that. Will crash, except yeah, that's to be expected. Where do we have that? Never happens. Never actually happens. So expression stream limit to first. Should be in Bootstrap parser. We only get Lexer output. So font symbol of type equals. And I think that's this one, isn't it? No, actually no. It just panics before it does anything else. Never get here? What is wrong with that? Like we could crash down here. Okay, fine. What if I revert it back so that it should compile? Oh, here we go. Maybe I didn't read far enough. Oh, wait. We don't even have multiply implemented in the lexer. Let's take a short detour. Let's implement, yeah, it can be more than just multiply, so. Let's quickly do that. Then we can have 0 times 3 plus 5, which of course should return 5 and not something like 8. Fantastic. That is to be expected. Okay, so start. Yeah, so the tokens all just print out their thing. Let's beautify that. Maybe we can see it better. So let's see. So I don't think that worked because we're not limiting the token stream correctly. So this contains all the tokens, like function is the first token. If you extract the comments. Or maybe we do index 10, index 18. Oh, wait. So the last one, integer literal, 85, 86, that might be the 5 actually. Actually, I think it's correct. We're just not setting the correct first value. And we actually want that because we want to be able to revert back to the start. So I think we want to just make a substream, and maybe we don't actually want this like length syntax. Maybe we just, I know that's not a good idea. Let's just have, yeah, and self. Can I just, wait, is that possible? Oh, right, so, okay. Okay, and I think that's even possible down here then. Yeah, okay. Much better. So basically we can just take the, yeah, we basically make substream just slices off all the beginning stuff and starts us back at 0 with a reduced number of tokens. So, blop. Let's see. Yeah, fantastic. So we have integer literal star integer literal plus integer literal. So we correctly get this, and we should above see one with just 2 tokens. Yep, fantastic. So now we have a token stream thing that just contains the expression, so we can like move around back to the start and so on if we need to. So I think that will make our lives much easier. Already 45 minutes and I haven't done anything today yet. Stay hydrated, and let's see if we can do this. Should be able to just does it complain about expected? Oh, just have to borrow mutably here. Let's comment that out for now. And now we have to, okay. Well, now we have to somehow figure out where this expression stream landed. So, maybe we want to well, the cool thing is because we have like source file indices, these source file indices, we can compare tokens for equality. So let's maybe try that. Import for token stream. Is it called? I don't even recall. Yeah, and I also need to have it partial equals. Wait, but I don't even need that on like token stream. I just need that on token. So I just have to do that in the lexer. Or do I already have that? Do I already have, where's token? Or can I just derive? Yeah, I can just derive that because we need to have the same type, same start, same end. Code will always be the same anyways, but let's just be safe. I think that's all we need. So we can just fn advance past other. So self and then just have the other stream. So yeah, we just while let some token equals self tokens next and self next actually. That's why we're not using the API up here. Oh, because we're not we don't want to be advancing, but in this case it's fine because we're actually advancing. Next. All right. It doesn't matter because maybe we just like if we don't, let's just have that as a behavior that we just advance the stream to the end if there's nothing matching. So if next token equals other stream dot look ahead 1 expected any token. Let's just have that let other token because that doesn't change, like we're not also not modifying the other stream. Other token break. There doesn't need to be brackets here. So yeah, so I think yeah we want to result of self and string. Just question mark that. And now we get oh, we need to x0. We need to okay self. And that is a modifying mutable. Why is look ahead modifying? Doesn't need to be. I was just dumb when writing the function. Okay. It's actually real quick. Yeah, the other ones are correct. Next definitely is modifying, and limit to first is definitely modifying, because we're changing self tokens here. Okay, but that should actually fine. So then we can just token iterator dot advance past other expression stream. And now we want to question mark that. And let's see if that works again. At least for the first one. The second one will not work because we can't parse this yet, but okay, checking type integer literal, but has integer literal. Error while parsing expected any token. Expected any token. Right. The other stream is already at its end. So I think that's expected behavior from advanced past other. So what we want to do instead is in parse statement, in parse statement down here, we want to, this is the parse expression. Like we probably want to extract this at some point, but for now, like the, what we want to do, I think, is like backtrack the expression stream once so that we find its last token. Expression stream dot backtrack 1. Okay, yeah, and we'll need the backtrack function anyways later on. And also with like other arguments, we might want a backtrack to beginning or something like that. Let's actually put that up with look ahead because it's the inverse, or it's the inverse of next. And error message, which is string, we get a result. Result of nothing. So yeah, backtrack is just intended for moving around, so it doesn't actually return anything except maybe an error. So if self self.index minus amount less than or equal to 0. Oh, I like this. This is a nice ligature. Ooh, these are super nice. I like them. Less than 0, then we error message to owned, else self.index minus equals amount not return. Okay, should be it. So now we need another argument. This is wait, explode. I don't know. Let's put in some Easter eggs. Yaxplode. Put that on screen right now. So let's see. Error while parsing. Yaxplode. Cool, we immediately hit that. So the expression stream, wait, self-index minus amount. So I want to see what that is. I can't type today. So, wait, I just moved out of this comparison involving the minimum or maximum element for this type contains a case that is always true or false. Because 0 is the minimum of, because we're dealing with use size here. That's super helpful actually. We need to limit those two. And now let's allow possible wrap, but just for this function. It might cause issues, but that's one of the things I usually disable, because it's not super helpful if I'm intentionally doing these kinds of casts. Okay, let's look at the 1 minus 1. Oh, right, I'm actually dumb. It needs to be less than 0. Because interpreted as start of generic arguments for I size. Okay, let's do this instead. So yeah, right, I'm dumb actually. Like it can be 0. That's perfectly fine. Okay, I think it works for the first time. Like we get 2, which is 1, 2. Like the plus is the first token, then we get the number. So we then decrement, and I think we have, we find the semicolon, so we do the advance correctly. And now the second time we crash, and that's to be expected. Like we're not parsing this anymore. Phew. So like I've done a lot of stuff today, but I haven't really started parsing anything of this. Like all we got now is parse expression can just go wild on its stream basically. Okay, so I think what we want to do first is let's try. So we want to so what we can now do is like look for the first multiply. I can now look ahead for the first multiply. So what we can do is we can look ahead for the first multiply, then parse anything to its left and anything to its right. And if that doesn't work, then we want to try the next one. Though of course we need to take into account things like brackets, for example. So if we have something like 0 plus 7 times 3 plus 5, for example, we can look ahead at the first multiply, parse anything to its left, which would be incorrect actually in that case. Okay, strange. How do I do this again? Oh my god. I need to first... I've not written enough like... this kind of parser. I've not written that at all, or like last time I did it, it was some sort of tutorial a couple years ago. I don't know. I don't remember. So 0 plus 7. So in that case... we want to, because we start from the left. So we first want to look, I think we want to look for the first like binary operator. If the first binary operator is a plus, or like a less strongly binding one, we want to parse left side and the entire right side as an expression? Or do we want to do that? Wait. So let me actually sketch that out. So if we put this in eBNF, in extended Backus-Naur form, which is a basic way of syntax, notating syntax. So we have expression that is factor, and we have times or divide, and that's not an optional, that's required. Factor times or divide factor. Then we have, I think they usually do it like that. Then we have factor, which is non-factor. Any other, let's just go with plus or minus for now. Non-factor. And non-factor can be either a factor or literal or function call or like something like binary op. Let me wrap that. Binary op and another expression. I think that's how that works. So, which basically means that we first try to associate anything that. No, that's not how that works. Oh my god, it's really hard to remember the details here. No. And the next thing we have to worry about is brackets. But I guess brackets, wait, so expression can be open brackets, close, it can be either this, so don't be confused, like these are terminal characters and these are just part of the EBNF syntax itself. Expression, or they can be expression. That's not Haskell. No, that's it. That's not Haskell. Just tried to boot up the Haskell language server. I mean, you can kind of write that in Haskell. That's you need to type as a prefix, but yeah. Expression times expression. I think that's how that works. And then we might also have, wait, no, this needs to be factor. And now factor can be another expression, or it can be an expression plus an expression. Plus expression. I think that's it. And we maybe we need like literals here, I think. Okay, so yeah, I think we need to try and parse multiplies first. Like basically search for the first multiply, parse any expression immediately to its left, which basically just means parse any literal to its left or anything bracketed to its left. Like don't parse another binary operation to its left. At least not an addition operation. Oh my god, this is really hard. And then there is a simple way of doing this. Anyways, Honestly, I think I have to do some research now on how this exactly works, because I can't remember at the moment. So I'm going to stop the stream now. See you on the next episode. Goodbye.